Okay, welcome back to 5.3, the third section of Unit 5. We are going to be looking at coterminal angles for this section. That's something new, okay? You have not heard of that before. But basically what we will be doing is we'll be looking at angles less than 0 degrees and more than 360 degrees, okay? So again, in first lesson, we only look at quadrant 1, so 0 to 90 degrees. Second lesson, we look at from all the quadrants, so 0 to 360. Now we're going to be looking at some angles that's less than 0 and angles that are more than 360. Okay, so now before we look at those, let's again look at some definition here. Principal angle, I think we saw this earlier, it's the angle in standard position that is between 0 and 360 degrees. So basically angle in standard position will be a principal angle because it's between 0 and 360. Okay, coterminal angles, this is new. They are two non-coincident angles that share the same terminal arm. So we're looking at two different angles that share the same terminal arm. Okay, they share the same terminal arm, but they are not the same angle. They are, okay, so non-coincident, right? They are not the same, but they share the same terminal arm. So they are what we call the coterminal angles. So you might think, well, how is that possible? Well, let's see. Let's see example number 1. It says, determine the measures of all angles in standard position between negative 600 degrees and positive 600 degrees that are coterminal with an angle of 200 degrees in standard position, and sketch the angles. Okay, so what I'm going to do right now is I'm going to draw 200 degrees first. 200 degrees is somewhere here because it's more than 180 but less than 270. So there is my 200 degrees. That's my principal angle. Okay, this is not my coterminal angle. This is simply principal angle. So the coterminal angle to this would be then one of them. So again, they share the same terminal arm. So instead of just rotating and stop right there, what you're going to do is you're going to rotate one more time and goes back there. So how do we figure out what this angle is? Well, because we rotated one extra revolution, so really the angle here, the coterminal angle would be 200 plus 360, right? You just added one more rotation. So this is 560. Okay? Now, you could rotate one more time, but then for sure it's going to be more than 600. So this is one answer. We could also do it this way, okay? So again, this is 200. Instead of adding one more rotation this way, what I'm going to do is I'm going to actually start from here. I'm going to go backwards, one full rotation. Okay, and you can see it stops right there as well, right? So this angle is actually, again, starting from 200. Now we're going backwards one full rotation. So instead of adding 360, we are going to take away 360. And this is negative 160 degrees. Okay, so actually when we draw this, we don't draw it like this. We actually simply draw it like this. Okay, so when we rotate clockwise, the angle is negative. Okay, so that's another coterminal angle. Again, if you rotate clockwise, it is negative. If you rotate counterclockwise, it's positive. Okay, so these two, you can see it's rotating counterclockwise, so the angles are all positive. This one is rotating clockwise, therefore the answer is negative. Okay, we actually have one more. We can rotate. Again, here's the terminal arm. We know this is negative 160. If we rotate one more round, right, one more rotation, then this becomes negative 160. Again, because we're rotating clockwise, so we need to take away another 360. This is negative 520. Okay, and you can see all these three angles, 1, 2, 3, are all between negative 600 and positive 600. So these three angles are coterminal angles with 200 degrees. Okay, so these three angles are coterminal angles with 200 degrees. Okay, so that's part A. Now finally part B. Part B asks us to write an expression for the measures of all the angles that are coterminal with angle 200 degrees in standard precision. So really what we were doing was we started with 200. We either add or subtract 360 degrees. So what we do is we go 200 plus minus 360 times natural numbers. Okay, I don't know if you remember what natural numbers are. N is the element of natural numbers. I guess the symbol for natural numbers is almost like, it's pretty much like an N, okay? Keep that in mind. And natural numbers are 1, 2, 3, 4, 5. Does not include 0, okay? 200 degrees is not coterminal with itself, okay? So 200 plus 360, or plus 360 times 2, or plus 360 times 3, and so on, or minus 360 times 2, and so on. Okay, so it's 200 degrees plus minus 360 degrees times n, where n is element of natural numbers. And again, natural numbers are 1, 2, 3, 4, 5, 6, 7, 8, and so on. Okay, so these are the coterminal angles. Okay, 1, 2, 3. And obviously not only these three, right? But these are the coterminal angles within this range. Okay. All right. Example number 2 is says determine the exact values of the 3 primary trig ratios for 750 degrees. All right. So 750 degrees. I think we did something similar in the previous lesson, but we dealt with angles that is between 0 and 360. Recall, to figure out the trig ratios, and if we're looking for exact values, what we need to do first is, again, finding the reference angle. Reference angle is key, okay? Now, how do we find the reference angle? Well, I know it's 750, okay? So if I take away 360, so basically what I need to do is I need to figure out what the principal angle is, right? If I can find out what the principal angle is, then I can draw it on the diagram, then I can find the reference angle easily, okay? So to do this, I just need to take away 360, and I end up with 390, okay? This is not quite principal angles yet, so then I just keep going, minus 360 again. This is 30 degrees, okay? So I shouldn't say this is the reference angle, this is the principal angle. Okay, so then once I know my principal angle is 30, then I can draw my diagram. That's 30 degrees right here. And it just happened to be that this is the reference angle, right? So reference angle happened to be exactly the same as the principal angle. So now what I can do is I can use my special triangles to solve the problem now. This is my 30 degrees. Okay, it looks like 36. 30. This is 60. Recall the ratio for the sides is 1 to root 3. 1 being the opposite side from the smallest angle. 2 is always the hypotenuse. So then we can go sine theta, cosine theta, and actually, sorry, not theta. We actually know it's 750, cosine 750, and tangent 750. Okay, sine is opposite over hypotenuse. Opposite side is 1, hypotenuse side is 2. Now we need to consider about the sines. Since 750 degrees is in quadrant 1, okay, in quadrant 1, therefore all the ratios will be positive. So I don't need to worry about the signs. Cosine would be adjacent, which is root 3 over hypotenuse, that's 2. Tangent is opposite over adjacent, so 1 over root 3. Okay, so let me just quickly go over this one more time. Here is the angle, okay, 750. Now we are looking for the primary trig ratios, which means I need to find the reference angle. Before I can find the reference angle, I need to find out where this angle locates, okay? So I need to figure out the principal angle. So to do that, I just simply take away 360 each time to go back 1 revolution, and until when I'm in my principal angle realm, I guess, so from 0 to 360. And so that's what I did, minus 360, and so on, okay? Why don't you try this one for negative 480? So think about, if it's negative 480, do we subtract 360 or do we do something else? Okay, you think about it. I'll show you the answer in a bit. Okay, so here we go. Instead of subtract 360, this time we should add 360 to make it positive. And if you do that a couple times, you should get your principal angle as 240. So here's my angle of 240. I can then find the reference angle. Be careful, I think the mistake that students make usually is that they think this is the reference angle, and so they thought it would be 30, but it's not, right? Reference angle, recall, is always between x-axis and the terminal arm. So here, the reference angle will be 240 minus 180, which is 60. Here's the special triangle again, and we take, once we have the special triangle and we have the reference angle of 60, we can then look from this angle, 60 degrees, and get the ratio. Now, because this angle is in the third quadrant, both sine and cosine would be negative. Recall, all students take calculus, right? So first two ratios for sine and cosine will be negative, but tangent will be positive because we're in the third quadrant. Okay? All right, example number 3. Again, I think we've done something similar here before. It says the point P, 5 comma negative 2. So I would draw the diagram first. 5 comma negative 2 is somewhere here. Okay, so that means the x value is 5. The y value here is negative 2. So I mean the height should be positive. Doesn't matter. Determine the exact value of the trig ratios for theta. So now what we need to do is we need to find the hypotenuse. So let me call this r. So a squared plus b squared is equal to c squared. This will be 25 plus 4 equals r squared. That's 29 is r squared. Therefore, r is square root of 29. Okay, so now we can find sine theta. Okay, so here is angle theta, right? Sine theta, cosine theta, and tangent theta. Okay, so sine theta would be opposite side over adjacent side. So here's the reference angle. That's where we look the triangle from. Opposite side is 2. Hypotenuse side is root 29. Now, because we're in the fourth quadrant, so sine should be negative. Cosine will be adjacent over hypotenuse, so it'll be 5 over root 29. Again, by looking at all students take calculus, cosine will be positive in quadrant 4, so we leave it like that. Finally, for tangent, that's opposite over adjacent, and tangent is negative in the fourth quadrant. Okay, so that's example number 3. Hopefully that was not too difficult. This really should be from the previous lesson, right? This, because we're only dealing with angles in the fourth quadrant, right? It's not more than 360 or less than 360. So this one's not too bad. More like a review here. Example 4, this is something, well, not really new. You just add one extra step to it, right? It's nothing new here, really. Okay. Anyways, part A says determine the exact values for other trig ratios of angle theta. It says suppose sine theta is a quarter. Now, again, based on all students take calculus, sine is positive in quadrant 1 and 2. Which means we actually have two cases because it did not tell us which quadrant it's in. Okay, so we have case 1 where the angle is in the first quadrant. So we would have a triangle like this here, 90 degrees, and here's my angle theta. Sine, the ratio for sine is opposite, so that's 1 right there over hypotenuse. We can find x by using, again, Pythagorean theorem. X squared plus 1 squared is equal to 4 squared. This is 16 minus 1, so that's 15. Therefore, x is equal to root 15. So in this case, we would have, okay, we already know sine theta is a quarter. Cosine theta, because we're in quadrant 1, so everything, all the ratio will be positive. Okay, so we don't need to worry about the signs. So cosine will be adjacent over hypotenuse, so root 15 over 4. And tangent theta would be opposite over adjacent, so that's 1 over root 15. Okay, so that's case 1. That's if the angle was in quadrant 1. Case 2, this is when the angle is in quadrant 2, right? Because sine is also positive in quadrant 2. we really have the same triangle, right? So 1, 4, and this would be root 15, which is calculated. So the ratios will be the same, except the signs could be different. We know that sine theta has to be a quarter, does not change, because I mean that's what it tells us. However, for cosine, it is no longer positive root 15 over 4. It's now negative root 15 over 4. And again, because all students take calculus, tells us that only sine is positive in quadrant 2. Therefore, cosine will be negative, so is tangent. So tangent would be, instead of 1 over root 15, it's now going to be negative 1 over root 15. Okay, so this is part A. Part B, it asked, to the nearest degree, determine possible values of theta in a domain negative 360 degrees to 360 degrees. So I'm going to split this in like this, right? Because 2 cases. So same thing for part B, there will be 2 cases. What we need to do first is, again, always find the reference angle. Okay, so we can easily find the reference angle by taking the inverse sine. Inverse sine of a quarter. Okay, I don't know what this is. I'll put this into a calculator. Okay, I struggle to find a calculator on me. It's kind of weird as a math teacher. Okay, anyways, inverse sine of a quarter is, what do we need to round to? Round to nearest degree. So this is actually 14.5. I mean, it's not really 14.5, it's 14.47. So if I round to the nearest degree, it's actually 14 degrees. Okay, 14 degrees. That's the reference angle, and because we're in quadrant 1, the reference angle is actually the angle itself. Okay, so our theta 1. Okay, so if I draw the diagram, it looks like this. Here is 14 degrees. So here's my theta 1 being 14 degrees. Now, because we are looking at this domain, we need to find the coterminal angle with 14 degrees because they would have exactly the same properties. Okay. Now, if I add 360 to 14, it's then going to take us outside of this range. Okay, so it's going to be more than 360. Obviously, if I add positive 14 to positive 360, it's going to be more than 360. So instead of adding 360, what I'm going to do is I'm going to take away 360, and I would end up with another answer. This will be negative 346. Okay, so there's my first answer, and there's my second answer. Okay, and that's for case 1. Okay, now for case 2, we already knew that the reference angle would be 14 because, I mean, it's the same thing, it's just in different quadrant. Okay, that's a bit off, that's okay. So here, this is 14. This is my reference angle, so this would be my theta 3. Okay, this is theta 1. This would be my third angle, and theta 3 would simply be 180 minus 14 degrees. This is 166. Okay, so that's my third answer. And again, if I add another 360 to find my coterminal angle, it's going to take us outside of this range, right? Because positive already, adding another 360 is going to be definitely more than 360. So again, instead of adding 360, I'm going to subtract 360. This, I believe, is negative 194 degrees. Okay, so that would be my fourth answer. And I mean, if you're not so sure, you can definitely continue to minus 360. But then I think it's quite clear, if you minus another 360, it's going to take you, again, outside of this restriction right here. Okay, so in this case, you actually end up with 4 answers. All right, so this is it for this lesson. Again, it's not something that's new, it's just kind of new, I guess, because coterminal angle is a new concept where you have more than 360 degrees or less than 0 degrees. But really, all you need to do is just add 360 or subtract 360 from the answer you got from the lesson that you learned in the previous sections. So anyways, do some practice questions. Let me know if you need help, and good luck.